All right, this is a video specifically for certain questions on the practice quiz with regards to graphing functions with the XY table and also graphing standard form equations with X and Y intercepts. So let's jump right in and let's begin with comparing what is function form compared to what is standard form. I hope we remember that the word form means the way it's organized, the way an equation is organized. So what is function form? Function form is simply when you have y by itself. Okay, so here's an example of a function form equation. Y equals, let's say, 2x plus 1. Okay, the reason why this is called function form, remember, a function is like a machine, and if you do have it set up like this function form where you have y by itself, it's really easy to plug in inputs and outputs, and that's actually how we graph. We need to remember that inputs are really x values and outputs are really y values. So again, the inputs are the x values and the outputs are the y values. And you could plug in any three numbers you want for x, or actually any numbers you want for x. It doesn't have to be three. You at least need 2 points to make a line. So on the instructions on the notes I gave you, I said that the easiest points to use most of the time are 0, 1, and 2. Now, 0 is always the easiest one to use, right? When you plug in 0 right there, 2 times 0 is 0, and 0 plus 1 is 1. So that's an actual coordinate of this equation. Then you could plug in 1. And when you do plug in 1 right there, 2 times 1 plus 1. 2 times 1 is 2, and 2 plus 1 is 3. And believe it or not, you already have 2 points right here. That's already good enough to graph your line. However, I recommend going for a third one. That way, if all 3 points line up, then you'll feel a little more confident that you got the right answer. So if you do plug in the number 2 for x, remember you're plugging in to the x. So here's the x, you're plugging in the 2 right in there. 2 times 2 is 4, and 4 plus 1 is 5. Again, these are 3 points, and if you did graph them on an xy plane, you will see that they line up. They are collinear, which means that most likely you did this correctly. And all you do is draw a line through these coordinates with arrows on it, and you have graphed the line in function form. Anyways, once again, what is function form? Y is by itself. Here's y. It's by itself. This equation's in function form. Now, there will be times where they will ask you, like, rewrite this equation, 3x minus 2y, let's say, equals 6. That equation is definitely not in function form. And they're going to tell you to rewrite it in function form. I apologize for the mess, but yeah, here are the instructions. Rewrite in function form. So you want to get y by itself. Remember, function form means y by itself. So you're going to get this y by itself by getting rid of the 3x. So you would subtract 3x, subtract 3x. You're going to rewrite it. That's going to be a negative 2y. Let's bring down the equal sign first. So on the left side, you're going to have a negative 2y because this canceled out. So all you had was a negative 2y on the left side of the equal sign. And then over here, 6 take away 3x. You can't really do it, so you're just going to rewrite it. And instead of writing 6 take away 3x, you're just going to write this x term first. The minus belongs to the 3x, so we're going to write 3x first and then a positive 6 second. So negative 3x first plus 6 second. And it's almost in function form. All I need to do is get rid of the multiplication of negative 2 right in front of the y. And how do you get rid of the multiplication of 2? You divide by that same value, negative 2 in this case. So divide everything by negative 2, and you will end up with your function form equation. Y equals a negative divided by a negative is a positive. So that'd be a positive 3 over 2. You can't really divide 3 by 2. And it has an x. And last but not least, 6 divided by negative 2 is negative 3. Okay, so I apologize for this mess. Let me separate my work. Okay, this is the first example I did graphing this one. The y was already by itself. We made an xy table. I didn't even actually graph it, but I came up with 3 points that we could graph on an xy plane. We'll get to do that in a little bit. And then there's another type of question they could ask you, rewrite in function form. So here's your equation. Y is not by itself. When they say rewrite in function form, that means get y by itself. Solve for y. Here's y, get it by itself. That's what we did. Y equals that stuff. That's function form. Likewise, if I give you this equation and I tell you graph it by rewriting in function form, well, you would change it to function form, and then you would use an input-output table to plug in values into X and pull out answers for Y. Anyway, I think that's enough for function form. Let's jump to standard form. What is standard form? Standard form is when you have AX plus BY equals C, okay? AX plus BY equals C. And you also need to remember that A, B, and C are just numbers. A, B, and C, just integers. That'd be a better thing to say, just integers. Now, what are integers again? They're just numbers that are either positive or negative, no fractions, no decimals, right? That's what we like standard form. A is a number, B is a number, C is a number. So an example of that would be something like 2x plus 3y equals, let's say, 12, okay? 2x plus 3y equals 12. This is in standard form. The A value is x, the A value is 2, the B value is 3, the C value is 12. And when it is in standard form, it's really easy to find the X and the Y intercepts, okay? When it's in function form, it's really easy to make an input-output table, plug in numbers, pull out answers like if it were a machine. But when it's in standard form, it's really easy to find X and Y intercepts. So how do we find an X-intercept? You find an X-intercept by setting Y equal to 0 and solving, okay? So how do you find the X-intercept? You set Y equal to 0 and solve, all right? How do you find the Y-intercept? You set X equal to 0 and solve. Man, this is getting messy. I apologize. But anyway, let me actually show you an example of that. Let me make some space here. So to find the X-intercept of this equation right here, we are going to set Y equal to 0, okay? So this is what you need to know. I'm going to put in a little cloud. That's what you need to know in your mind. So when I rewrite my equation, 2x plus 3y equals 0, you're going to write it as 2x plus 3y, but notice that you need to set y equal to 0. So instead of y, put parentheses, and then it says equals 12, right? 2x plus 3y equals 12, 2x plus 3y equals 12, but we put parentheses instead of y because y equals 0. We're going to put a 0 right in there. And that becomes really easy to do because 3 times 0 is 0. You could just ignore it. It's like if you just had 2x equals 12, and that's a one-step equation that you could solve. Divide by 2, x equals 6. So this is not an answer to the equation. This is the x-intercept, all right? We just found the x-intercept. So what this is saying is that it's going to cross your x-axis at 6, okay? And if you wanted to find the y-intercept, you would set x equal to 0 and solve. And this is what you need to know in your head, okay? So, and you know what? It's even easier than actually doing this math. If you really wanted to, you could just get your finger and cover up the term that has the x on it. Because if you look up here, 2x, if I were to plug in a 0 right there, then that would just become 0. That would just pretty much disappear. So what I'm going to do, instead of plugging in, I'm just going to cover it up because 2 times 0 is 0. And I could just do this in my mind. 3y equals 12. All you have to do is divide by 3 and divide by 3, and y equals 4. So y equals 4. And that's my y-intercept, okay? That's my y-intercept. So if I know the location of my x-intercept, so it's going to cross the x-axis at 6. We know that this is the x-axis, so you go to 1, 2, 3, 4, 5, 6. Let's say it crosses right here, okay, at 6. And we know that it's going to cross the y-axis at 4. So that's going to be crossing at 1, 2, 3, 4. And you put a dot right there. And if you have 2 dots, that dot and that dot to a line, then pretty much you could already draw your line, and that's it. So you could actually use the x-intercept and the y-intercept to graph. Some people would argue that doing the graphing with x-intercept and y-intercept is even faster than using the input-output table on a function form equation. But I'll leave that up to you to decide which one you would rather use. Let's actually jump into some questions that were on the practice. Here we go. This one right here, on the practice test, practice quiz, they give you this standard form equation and they want you to graph it. Now, they don't tell you what method to use, but I'm telling you right now that if it's in standard form, it's a lot easier to find the x-intercepts. and the y-intercepts. By the way, this is the incorrect graph. This is the wrong graph. So let's actually find the x-intercept. How do we find the x-intercept? We must set y equal to 0 and solve. Again, this is what you need to know. You need to set y equal to 0. So when I rewrite this thing, it says negative 3x plus 2y equals 12. Negative 3x plus 2y equals 12. Negative 3x plus 2y equals 12. Why did I put parentheses instead of y? Because I know that y equals 0. They're telling us to set y equal to 0. So inside where y used to be at, in parentheses, I'm going to plug in the 0. And that becomes super easy because that's kind of like it canceling out. It's kind of like if you could just cover it up. And now you look at that simple equation, that's like a one-step equation, right? Negative 3x equals 12. Just divide by negative 3, divide by negative 3. You already know your x-intercept is negative 4. That's if you wanted to cover it up and do it that way. Or you could just actually do your work, right? 2 times 0 is 0. Rewrite it. Negative 3x equals 12. How do you get rid of the multiplication of negative 3? You're going to divide by negative 3, divide by negative 3. And you're going to get your x-intercept. X is negative 4. Okay, so this is your x-intercept. That's telling you that it's going to cross the x-axis at negative 4. Now, if you actually wanted the actual coordinate, that would be the coordinate negative 4, because x is negative 4. Remember, x is first, y is second. And where did this answer come from? It came from us plugging in y equal to 0. So that means that this y value is 0. Okay, so this is the actual coordinate of the x-intercept of this equation. But the bottom line is, if you're just trying to graph x equals negative 4, it's telling you that your line is going to cross the x-axis at negative 4. So on your quiz, you have to get either this point or this point and drag it to the x-axis to negative 4. And there'll be a dot right there. Let me actually put that dot in green, that dot right there. And then you still want to find the y-intercept. Okay, so let's write that down. Y-intercept. How do we find the y-intercept? We set x equal to 0. This is what you need to know to be able to find the y-intercept. You set x equal to 0 and solve. So when I write this out, negative 3x plus 2y equals 12. When I write it out, negative 3x plus 2y equals 12. Of course, instead of x, I put parentheses because x is supposed to equal 0. So I'm going to plug in a 0 right there. And that becomes really easy because negative 3 times 0 disappears because it's 0. And I have a simple one-step equation. This is really saying 2 times y equals 12. So I'm going to divide by 2 and divide by 2. That'll give me y equals 6. Again, this is the y-intercept. It's going to cross the y-axis at 6. If I actually wanted the coordinate for the y-intercept, then you need an x and a y value. Of course, the y value is 6. What's the x value? Well, we set x equal to 0, so that must be 0 for the x. 0, 6. Okay. So anyways, however you look at it, we know it's going to cross the y-axis at 6. Here's the y-axis. Go to 6. Put a dot right there. So on your quiz or practice quiz, you're going to have to take this dot, put it here, take that dot, put it up here, and it's going to give you that line right there. Okay. So this is the line that it'll produce, arrows. And that's how to graph it using standard form. Let's do a couple more with standard form. Another one, and this one I want to do it a quicker way, right? We know that to find the x-intercept, we must set y equal to 0 and solve. So that would imply that wherever I have a y, I put parentheses and I plug in a 0. So that's what I'm going to do. I'm going to rewrite this thing, but instead of y, I'm going to put parentheses. That says 4x minus 8y equals 24. 4x minus 8y equals 24. And of course, I am plugging in a 0 right in there. And that just simply cancels it out. I might as well just do this math. 4 times x equals 24. How do I get rid of the multiplication of 4? I divide by 4, I divide by 4, x equals 6, right? Now, I could have done this same exact work by simply covering up my y, because this is going to end up being 0. So if I wanted to, I could just cover it up like that. And it's just a one-step equation. How do you get rid of the 4 in front of x? Divide by 4, divide by 4. The answer is 6. And that'll be an x equals 6, which means that the x-intercept is 6. If you actually wanted the coordinate of where your line will cross the x-axis, you put the x value of 6, because that's what it is, and the y value of 0, because that's what you set, equal to 0. So that's an actual coordinate, okay? Now let's do the y-intercept. instead of showing the work, I'm just going to cover it up, right? What do I mean by that? How do you find the y-intercept? Well, you set x equal to 0. So as you can see, x is right here. So yeah, if I put in 0 right there, it's going to become 0. It's going to cancel out. I'm just going to simply cover it up. And look, it looks like a one-step equation, and it is a one-step equation. If I plug in 0, it would disappear. So all I have to do is divide by -8 and divide by -8. 24 divided by -8 is -3. So I know my y-intercept. My y-intercept is going to be y equals -3. Okay. Of course, you should show your work. I recommend showing your work, especially on the quiz or test. So you know what? Yeah, it's probably a better idea to actually show our work here. Let me erase this. Let's go back. So showing our work, we're going to find the y-intercept by setting x equal to 0. That's going to become 0. So 4x minus 8y equals 24. Show your work. 4x minus 8y equals 24. Okay. And of course, we are plugging in a 0, which means that it disappears. What's left? We have -8 times y equals 24. Divide by -8. Divide by -8. Cancels out. Y equals -3. Okay. So the y-intercept is -3. If I wanted the actual coordinate of where my lines are going to cross the y-axis, that would be an x value of 0 and a y value of -3. X value of 0, y value of -3. Okay, so how are we going to show this on the graph? We are simply going to grab the points and move them according to our x and y intercept. So if this one crosses the x, the x-intercept, it tells us that it crosses the x-axis at 6. So grab your dot, move it to 6 on the x. There it is. It's actually already on there. And this one tells us that it crosses the y-axis at -3. So take the other dot and move it to the y-axis on the -3, which it is. And there's your final graph. Let's move on. This one's not in standard form. This one is in function form, okay? Function form. And when it's in function form, it's really easy to make an input-output table, an XY table, right? The X's are your inputs. Why? Because you're going to put in numbers into the X. The Y's are your outputs. Why? Because when you work out the math, it ends up saying Y equals that answer, okay? So let's pick some easy numbers. Most of the time, 0, 1, and 2 work. You don't even need 3 coordinates. You only need 2. So if you do plug in 0 right there, -2 times 0 is 0, and then 0 plus 8 is 8. Okay? So 0, 8 is a point. So if you know that that's a point, you might as well grab this one and move it to 0, 8, all the way up here and put it up here. So drag this dot all the way up here, and that becomes your new point right there at 0, 8. Okay? Now let's do another one. The other point would be plugging in 1. So if you plug in a 1 right there, it's going to say -2 times 1, that's -2, and -2 plus 8 is 6. So that would be a 6 right here. Okay, so when I plug in the input 1, I get the output 6. My x value is 1, my y value is 6. So you would take this other one, this one you already moved up there, and you take this other one and move it to 1, 6. So you'd go 1 on the x, 6 on the y, you put a dot there, and that would be your point. So if you put those 2 dots on the xy plane like that, you're going to see that that's your line, and that's the correct answer right there. Now, of course, if you were doing it by hand, you're going to have to make this line a little bit longer. That's where you could continue using the pattern from one point to the other, down 2 over 1, down 2 over 1. You'd put a dot right there, and you continue to go down 2 over 1, down 2 over 1, down 2 over 1. Depending on how long you want to make the line, that's what you would do. Keep going down 2 over 1. And as you can see, it's perfectly straight. So there's your final answer. Now, with the program that we're using, all you got to do is drag your 2 points, this one and this one, to that first point that we said and that second point that we said. And that would be your final answer. I didn't even get to the third coordinate. But if I did get to the third coordinate, plug in 2 right there. -2 times 2 is -4, and -4 plus 8 is a +4. And as you could see, +2, +4, that's a dot on the line. So I hope this helps. Let's move on to another one that is in function form. Now this one's a little bit different. Why? Because you actually have a fraction in front of your x. You have a fraction in front of your x. So when you make an input-output table, And why am I making an input-output table? Because this is in function form. And when it's in function form, it's really easy to plug in easy numbers, right? 0 is always going to work. I love 0. When you plug in 0, it always works because anything times 0, doesn't matter if it's a fraction times 0 is still going to be 0. And 0 take away 4, obviously that's -4, okay? So that is an actual point on the line. So what I would do to start graphing this, I would take this dot and drag it down to 0, -4. That would be down here, okay? 0, -4. But we need more points, right? And if you did try 1, it's going to get ugly because when you plug in a 1, 3/2 minus 4, dang, a fraction minus a number, you need a common denominator. That's not fun, right? So let's not even mess with that. What other numbers would be better to use that when you plug in here, you have to multiply by this fraction? Obviously, when you multiply a fraction by its denominator, the fraction disappears. So that should tell you that the input of that denominator, 2, if you plug in that exact number, if you plug in 2 right there, so instead of 1, let's jump to plugging in 2, okay? And when I plug in 2 right there, it's going to say 3/2 times 2 minus 4. And of course, when you multiply a fraction with its denominator, they cancel out, and you end up with no more fraction, just 3 take away 4, which is -1. So when you plug in a 2, you get out a -1. And that would be 1, 2 on the x and a -1 on the y. That'd be a dot right here. And that's already good enough to draw your line, okay? So on your program, to be able to graph this, you take this dot, drag it to here, take this dot and drag it to there, and it'll draw a line for you right through those 2 dots. Now, if you're drawing it by hand, then with these 2 dots, it really is enough. You could just draw your line right through it. Or you could get another point by plugging in another input. So when you do have a fraction, I recommend using 0 for sure, because 0 always works. But then use the denominator, and then maybe the denominator doubled, or maybe the negative denominator. So plugging in a -2 would be good, or plugging in a 4 would be good, right? I'm just going to plug in a 4 just to show you. When I plug in a 4 right there, it's going to read 3/2 times 4 minus 4. And of course, you could multiply first. 3 times 4 is 12. Divided by 2 is 6. Or you could divide first. 4 divided by 2, that's 2. And 3 times 2 is still 6. It's totally up to you, right? So if you did want to multiply first, go ahead. 3 times 4 is 12. And 12 divided by 2 is 6. And 6 take away 4 is 2. So when I plug in a 4, I get out a 2. So as you can see, and instead of using 0, 1, and 2, we use 0, the denominator, and double the denominator. So if that would have been a 3 down here, I would have used 0, 3, and 6, or maybe 0, 3, and -3. But anyways, if we go to the coordinate 4, 2, 1, 2, 3, 4, up 2 would be a dot right there. And as you could see, it lands perfectly on this line, okay? So on the program, when you drag your 2 dots to any of those 2 points, it'll draw the whole line for you. So you don't have to worry about it. Anyway, that's what you do when you have a fraction in front of x. When it's in function form and you have a fraction in front of x, you don't want to use 0, 1, and 2. Always use 0, but then use whatever denominator you have. Check this one out. This one has a denominator of 3, okay? So it's in function form. Y is by itself. So we're going to jump right into an input-output table. We're going to use easy numbers. The easiest number to use is 0, because 0, when you plug it in, times anything, even if it's a fraction, even if it's a negative fraction, times 0 is going to be 0. And then 0 plus 7 is the easy answer, 7. So 0, 7 is an answer. So what I would do is take this dot and go to the coordinate 0, 7, 0, 7. So drag it up to here to 0, 7. Okay. And then after that, we need more points. Would 1 be a good idea? No, because you end up with fractions. Would 2 be a good idea? No. Remember, use the denominator and then maybe double the denominator, or maybe a negative denominator. So I'm going to, instead of plugging in 0, 1, and 2, I'm going to plug in 0, 3, and 6. Or maybe I could use 0, 3, and -3. For the sake of this video, I'm going to use 0, 3, 6, and -3. I'm going to plug all 4 of these in. I already plugged in 0. Check out how awesome it is to plug in 3. So here we go. We have a -2/3 times 3 plus 7. And again, why did I use the denominator? Because when you multiply a fraction by its denominator, it cancels out and you have no more fraction. So what we end up with right here is negative 2 plus 7, which equals 5. So when I plug in a 3, I get out a 5. How about when I plug in a 6? Well, let me rewrite this guy right here, negative 2/3 times 6 instead of x. So here we go, negative 2/3 times 6 instead of x, and then plus 7. So this also works out beautifully because I could multiply, then divide, or I could divide first and then multiply. So since I have a 6 and a 3, this time I'm going to just say 6 divided by 3 is 2. And then I could multiply negative 2 times 2. That'll be a negative 4. And of course, bring down this plus 7 right next to that minus 4. And negative 4 plus 7, that is equal to 3. So when I do plug in a 6, I get out a 3. Okay? And last but not least, I'm going to rewrite this thing, but this time I'm going to plug in a negative 3. Okay? Mind you, you only need 2 points. But right here, just for the sake of showing you all the best options for plugging in when you have a fraction, I plugged in the denominator, double the denominator, and even the negative denominator. So here we go. Let me rewrite the whole thing. Y equals negative 2/3 parenthesis. And instead of x, I'm going to plug in the negative 3 this time. Negative 3. And then we have plus 7. Plus 7. So the negative 3 and the 3, they do cancel out. But you have a negative 2 times a negative 1. Okay, negative 2 times negative 1. A negative times a negative is a positive. Okay, so that would be a positive 2 plus 7. That's going to give me 9. Okay, that might be a little confusing to some of us. Maybe I should go back here. It might be a little easier to do this. How about this? What if I had the negative 3 right in here? And maybe it might be easier to understand it. What is negative 2 times negative 3? Oh, that's positive 6. And then what is positive 6 divided by 3? Oh, positive 6 divided by 3 is 2. And what is, bring down the plus 7? 2 plus 7, that is 9. So when I plug in a negative 3, I do get out a positive 9. Okay? So we have 4 points. You only need 2. 0 was super easy. 0, 7's right there. 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Put a dot right there. And how about 6, 3? 1, 2, 3, 4, 5, 6, and up 1, 2, 3. That's right there. And how about this one? Negative 3 on the x, 9 on the y. Negative 3 on the x, 9 on the y. Whoops. Negative 3 on the x, 9 on the y, way up here in between 8 and 10. And as you could see, all of these dots line up. They're all collinear. Now, I just graphed it. If you were graphing it on paper and you wanted to show 4 dots, that's how you would do it. Technically, you only need 2 dots, the 0, 7, and 3, 5, 0, 7, and 3, 5. And even from there, you could actually use the pattern of the slope, down 2 over 1, 2, 3, and then down 2 over 3, or you go backwards, over 3, up 2, over 3, up 2, over 3, up 2. But if you wanted to find the best inputs to use, you're going to use 0 always, the denominator, double the denominator, or maybe a negative denominator. Okay, so I hope this helps, guys. Good luck on the quiz.